So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be proving this amazing identity. And this looks pretty amazing, isn't it? Let me just uh, let me just explain you a little bit about this. Let me just talk about this a little bit. So basically it's gamma of 1 over n times gamma of 2 over n and dot 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 all the way up to gamma of 1 n minus 1 over n, right? Obviously, because if we talk about gamma of n over n, so it's just gamma of 1, which is just 1. So yeah, it's just yeah so basically it's n minus 1 over n, right? And gamma of n over n is just 1. So if you want to consider that, you can consider, but it doesn't make any sense, right? Okay, so basically we have to prove this equals to 2 pi whole to the n minus 1 over 2 and over n to the 1 over 2. So this is what we are going to prove in this video. And you know what, actually I proved an identity. It's been, I think, 2-3 weeks, but and that identity is basically for this like identity actually. And I'll tell you wherever I'll be using that identity, I'll explain to you again. And yeah, I have proved that, and I have a YouTube, like, I'm sorry, I have a video over that, like, of the proof of that. So yeah, and I'll paste the link of the proof of that identity in the description box of this video. So yeah, so let's just talk about the proof of this. Okay, so basically we can write this as it's the product as k goes from 1 to n minus 1 of gamma of it's k over n, right? And we have to prove it to 2 pi to the n minus 1 over 2 over n to the 1 over 2, right? So let's just talk about this. So our first step is let p equals this product, actually this left hand side of our, like, target actually, right? So it's gamma of 1 over n times gamma of 2 over n and dot 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 all the way up to gamma of n minus 1 over n. And look at this part carefully. This can be written as 1 minus 1 over n, right? So basically I'm just gonna write some terms, like some lost terms, like of this product, some sort of that. So it's gamma of 1 over n times gamma of 2 over n dot 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 gamma of 1 minus 2 over n and times gamma of 1 minus 1 over n, right? So let's consider this equation as first, right? And let's just write this equation in the reverse order. So again, it's gonna be representing the p only because it's this product actually. So it's I'm talking about p equals 1 minus 1 over n times gamma of 1 minus 2 over n and dot 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 all the way up to gamma of 2 over n and times gamma of 1 over n. And consider this equation as second equation, right? Okay, and now multiply the first and second equations actually. And why I'm doing that, you'll get to know in a while. But yeah, that's gonna be giving us an interesting, amazing like bridge to just pass through it actually. So it's gonna be p times p, right? So it's p times p equals, if we talk about this one, so it's gamma of 1 over n times gamma of 1 minus 1 over n, the first terms of the respective equations, and the second term is gamma of 2 over n and times gamma of 1 minus 2 over n, right? And if we talk about further, so yeah, that's gonna be some sort of like values. Well, we'll not talk about them. So yeah, it's gonna be helping us out. Okay, guess what, here it's just p squared equals gamma of 1 over n times gamma of 1 minus 1 over n and then gamma of 2 over n times gamma of 1 minus 2 over n. Okay, So if you're a daily viewer of my channel, so you are familiar with this one, Euler's reflection formula into, and I have proved this down as well. It's gamma of z times gamma of 1 minus z equals pi over sine pi z, right? So yeah, for our case we have some z's, as when we have to plug z equals 1 over n, and it's gamma of 1 over n times gamma of 1 minus 1 over n. Here's the first part of this p squared, so that's going to be giving us pi over sine of pi over n. And if we talk about when z is 2 over n, so that's going to be giving us the second part, that is this one, as pi over sine of 2 pi over n. So that is the thing, and it's not the thing yet. We are going to use some better results as well, the one which I have talked about in the very beginning of this video. So it's p squared equals, it's pi over sine pi over n times pi over sine 2 pi over n, and yeah, that's gonna be giving us all the way up to pi over sine n minus 1, because we have talked about n minus 1 terms in the beginning. Yeah, you might have noticed, obviously you did. So yeah, here it is. So yeah, okay, so this is the product, p squared actually. And now we are having pi times pi times pi all the way up to pi, and these pi's are n minus 1 times, so it's gonna be p squared equals pi to the n minus 1, right? And we are having sine of pi over n and sine of 2 pi over n, and dot 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 all the way up to sine of n minus 1 pi over n. So this is what we are having so far, right? And yeah, and here comes the part which I was talking about, that I'm just gonna use the property. And guess what, you know, if you have watched that video in which I have proved an identity, which was sine of n theta over sine theta equals 2 to the n minus 1 sine of theta plus n pi, oh wait, I think it was pi over n, I'm sorry, it's pi over n times sine theta plus 2 pi over n, and dot 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 all the way up to sine theta plus n minus 1 pi over n. And this is the crucial identity of, obviously, along with the Euler's reflection formula, and I have proved this one as well. And again, I'm just gonna paste the link of both of these things in the description box of this video, the very first of this one, and we would be talking about this one as well. So yeah, and how I'm gonna use this, basically we have to take limits as theta tends to 0, and we know that sine of theta when like theta tends to 0, or let's say that you have sine of n theta when theta tends to 0, right? So basically when theta tends to 0, it's gonna be n theta only, right? It's just the angle, because sine is just like when angle decreases, the value of sine is also decreases, right? And so for sine of theta when theta approaches 0, it's just theta, right? So yeah, basically when we take limit as theta tends to 0 of both hand sides of this equation, sine of n theta over sine theta equals limit as theta tends to 0 of 2 to the n minus 1 sine of theta plus pi over n times sine of theta plus 2 pi over n, and all the way up to sine of theta plus n minus 1 pi over n. And guess what, when theta is 0, actually these all thetas are gonna be 0, right? And on the left hand side we would be having n theta over theta, right? Because we have talked about this, theta is decreasing, like when values, like when arguments decreases, theta, the value of sign also decreases, right? And yeah, okay, so here we are having on the right hand side as 2 to the n minus 1 times, when theta is 0, it's sine pi over n times sine 2 pi over n dot all the way up to sine n minus 1 pi over n. And guess what? Here we are having n equals 2 to the n minus 1 sine pi over n times sine 2 pi over n and dot all the way up to sine n minus 1 pi over n. And we are gonna divide both sides with this product actually, right? So that's gonna be giving us, and dividing both sides with n as well, so it's 1 over this product. And I'm just gonna write this as like in the big pi product actually, rotation actually, it's n minus 1 k is going from 1 to n minus 1, and it's sine of k pi over n, and it's coming out to be 2 to the n minus 1 over n. And here is the thing that we are here for from this identity that's gonna be helping us to prove that down. Look, we are having 1 over this product, and this is the product up to k minus 1, I'm sorry, n minus 1 from k equals 1 of sine of k pi over n. And this is being like we have resulted it out to 2 to the n minus 1 over n. So basically it's p squared is coming out to be 2 to the n minus 1 times pi to the n minus 1 over n. Look at this. So wait, yeah, here it is. Wait, where is that? Okay, here it is. Yeah, so this is just 2 to the n minus 1 over n, right? And yeah, so basically we are having p squared as 2, we can combine 2 pi to the n minus 1 over n and taking square root both sides, so that's going to be giving us p equals 2 pi to the n minus 1 over 2 over n to the 1 over 2, and hence proved, guys. So this is the thing that we are here for. And yeah, that's amazing, that's literally amazing. And I love to prove this down. Wait, it's 1 over 2. So yeah, just tell me guys, did you like this video or not? And I hope you did like this, because we have did a lot of things, not a lot of things, but yeah, we did a lot of like good things actually, which are impressive, isn't it? So yeah, so again guys, if you got to learn something out of this video, please make sure to like, subscribe and share. And if you have any kind of doubts so far, you are free to ask me in the comment section. I'll be there to reply over your questions. And I'm gonna paste the links of like the proof of this one and this one as well, so that you won't get any kind of confusion, because these two are the prerequisites of this proof actually. When you are done with this one and when you are done with this one, you will be easily done with this one. So yeah, if you're watching the proof of this one, I would request you to just watch the proof of the Euler's reflection formula as well as this one as well. So and I'm just gonna paste the link of links of those videos. So goodbye guys, take care, love you, and just love mathematics, learn mathematics, and love your life as well. Please don't hate it, because we have just got a limited time. Yeah, goodbye guys.